The sun is rising on solar power, which now accounts for around 2/3 of new electricity capacity globally. If the popularity of my recent video on the Strait of Hormuz is anything to go by, a lot of people are now considering solar power. Some may gravitate towards it out of a desire to choose the most eco-friendly option, but many more are now choosing solar as a way to save money. Right now, there are a lot of incentives to adopt renewable energy, but many people are hesitant due to various myths or misleading information about green energy generally, and solar in particular. Is it really reliable? Is it safe? Could it really save you money? Hi, I'm Dr. Eleanor Tufnell, an environmental scientist. In this video, I shall be going over several myths relating to solar power's reliability. This is the start of a series of videos on myths relating to solar energy. If it does well, oh, who am I kidding? If this video does terribly, I will still be making future installments. But if it does well, I will bump them up the priority list. So with that, let's get to our first myth. Myth 1. Solar means no power at night and in the winter. I'm sure you've heard this one. You may even have thought it. Solar power can only generate energy while the sun shines, right? Isn't it useless at night and in winter? So doesn't that mean at night we're at risk of blackouts, damaging our energy security? It's a common argument that more northern, colder countries that get less sunlight will get little to no benefit from solar power. This could not be more wrong. Pop quiz time. Can you guess where the most northern solar farm is? If you guessed, it's on the Svalbard archipelago at the latitude of 78 degrees, roughly 1,100 kilometers from the North Pole. That's weirdly specific, but also correct. Norway installed solar and storage at the Isfjord Radio and weather station in 2023. My apologies to any native Norwegian speakers. You'd think so far north, solar power would be pretty useless, but you'd be wrong. While Svalbard is in total darkness from the end of October to the middle of February, from April to August, the sun shines 24 hours a day, and the farm's battery packs and thermal storage are fully charged up during this time. While the stored energy cannot fulfill the station's energy needs year-round due to the prolonged darkness, the solar farm and its storage has cut diesel consumption by around 60%. While I'll cover the effect of renewable energy on wildlife in another video, I would like to note that solar panels at Isfjord have provided safe nesting sites for Svalbard's smallest bird, the snow sparrow. Allowing them to nest out of the reach of Arctic foxes. Modern solar panels can generate energy from diffuse light on cloudy days and do not need direct sunlight to operate. Naturally, the quantity of energy generated will vary depending on cloud thickness, efficiency of the solar panels, angle and placement of the panel, and the season. But even a reduced output can still provide surprising amounts of energy. Myth 2. Solar is unpredictable and unreliable. Far from being unreliable, solar is extremely reliable on an annual basis. Why? Because the precise time of daily sunrise and sunset can be calculated, and from this the number of daylight hours. From this, one can forecast the yield of electricity from solar systems with remarkable accuracy. Solar tech is also very reliable, and provided it is properly maintained, should last decades. With improvements in energy storage technology, excess solar energy can be easily stored for later use, which smooths out peaks and troughs in energy demand. In some parts of the world, such as Hawaii, Saudi Arabia, and South Africa, it is possible for solar to provide close to 100% of needed energy, 24 hours a day, 365 days a year. Though, of course, not every area that can do this actually does, but the potential is there. Even Birmingham, UK, which is not known for being the sunniest place, could obtain roughly 62% of its energy needs from solar. Additionally, complaints about how unreliable solar energy is ignore the fact that solar does not need to provide all our power needs alone. Solar and wind power complement each other well, as the daily and seasonal cycle experienced by wind and solar energy means that they operate at their best at different times. For example, in winter, when solar output is more limited, winds tend to be higher. Winds continue to blow throughout the night when demand for energy is usually lowest, thus topping up the batteries until solar can take up the next shift. So a combination of technologies, such as solar and wind power, can be combined with energy storage to smooth out fluctuations of supply and demand on the power grid. The argument has long been that because renewables are so unpredictable and unreliable, that fossil fuel-generated power is necessary for a stable grid. But with today's technology, this is just no longer the case. A grid powered by green energy can be balanced on both short and long-term scales. Far from damaging energy security, adopting green technology, such as solar, can improve the reliability of electricity networks. The EU, for example, has a comparatively high solar share, with a little over 22% of EU power coming from solar in 2025. The EU has a far more reliable electricity network than, for example, the US, which has a much lower share of its energy from solar, around 7% in 2025. Germany has seen a surge of solar and wind energy in recent years, with their combined share rising from 2% to 43% over the last 25 years, without impacting the security or reliability of the country's power supply. Myth 3. Heat waves reduce solar panel efficiency substantially. Many myths about solar energy have their roots in the early days of renewable energy, and rely on you not knowing that technology has advanced considerably since then. This, however, seems to be a newer myth, and it goes along the lines of heat waves make solar panels significantly less efficient, and they even need to be taken offline if they get too hot. And this is simply not the case. Like many myths, this one has a tiny kernel of truth at the centre, which has been heavily distorted. You see, at high temperatures, solar panels are marginally less effective. I do mean marginally too, because it is an extremely small change. Performance falls by between 0.2 and 0.5% for every degree above 25 degrees C, and this is usually more than compensated for by the energy increase from extra hours of sunlight. I should probably remind everyone that these things are being built in the deserts of Saudi Arabia, where temperatures can exceed 45 degrees C, that's 113 degrees Fahrenheit, and in the California deserts, where temperatures can approach 50 C, that's 120 Fahrenheit. If they can handle the heat there, they can handle a heat wave in, say, Birmingham in the UK. Sorry to pick on you, Birmingham. The heat range tolerated by most solar panels is usually between minus 40 degrees C and plus 85 degrees C. That's minus 40 degrees Fahrenheit to 185 Fahrenheit. It should also be noted that other sources of power, such as gas and nuclear, are also impacted by extreme heat, as this reduces their cooling efficiency. Myth 4. Solar panels cannot handle what nature throws at them. Climate change is causing an increase in the severity and frequency of extreme weather events. We've discussed heat waves, but they're not the only weather-related event that could affect solar panels. Hail, severe storms, high winds and snowstorms can all damage solar installations and will all be more of a risk as climate change continues. Every so often, a serious event such as a bad hailstorm will damage solar panels, and this will be taken as evidence that green energy is vulnerable and simply cannot handle the harsh elements. But how vulnerable are solar panels really? As it turns out, not very. A recent study that looked at solar farm data between 2008 and 2022 showed that following an extreme weather event, the median outage length was 2 to 4 days and resulted in only a 1% median loss in annual performance. Of the solar panels projects examined, less than 0.2% had outages of 2 weeks or more. Unsurprisingly, the more severe the event, the greater the impact on the solar facility. It should also be noted that all energy production infrastructure has vulnerabilities to extreme weather events, including energy generated by fossil fuels. High temperature, droughts, floods, fire, high wind, ice, extreme cold, and storms can all damage traditional power infrastructure. A mixture of power facility types and locations actually increases the grid's resilience to extreme events, as different power generation types and locations are unlikely to be impacted uniformly. Arguably, relying on only a handful of power plants using fossil fuels actually increases a power grid's vulnerability. Another point to bear in mind is that there are many steps that can be taken to better weatherproof solar panels. Fun fact, but the vast majority of utility-scale solar projects are equipped with trackers and the ability to turn the panels during the day. This is done so they can follow the sun, but could also be used to put them in stow mode, tilting the panel to 60 to 75 degrees during severe events to mitigate or avoid damage, not just from hailstorms, but hurricanes, snow, and floods. This can be done manually, but increasingly sophisticated weather prediction software means that this is now possible for all of this to happen automatically. Solar panels are also being built to be more resilient and resistant to damage from hail and other extreme weather events. Conclusion. Now that was a lot to take in, so allow me to sum it up for you. That is what a conclusion section is for, after all. Firstly, improvements in solar technology means that previous limitations in the form of cloudy days do not present a significant impediment to solar power, as panels can remain remarkably efficient even on heavily overcast days. Combined with other green energy technologies such as wind, and with the increasing efficiency of energy storage options, it is now entirely possible to gain all our power from renewables without the need for fossil fuels. Regardless of what latitude a country is, solar can be an important source of energy, and for particularly sunny regions, close to 100% of energy needs can be met with solar. Extremes of temperature or weather can impact solar facilities, but the effect is minimal. Extreme heat reduces solar panel efficiencies, but this is balanced out with greater daylight hours. Extreme weather events such as hail have minimal impact on solar efficiency, and solar facilities are increasingly able to weatherproof their panels. I really hope you enjoyed this deep dive into the efficiency of solar energy generation. As always, I've included a library of links in the description if you want to dig into the topic in even greater detail. I will be making more videos on this topic, so please do hit the subscribe button so you don't miss them. I would also appreciate any likes or comments you leave, both personally and because it tells the algorithm to show my video more widely. Please do share this video with anyone you think might find it interesting. So until next time, thank you for watching.